All right, I think we're live. Let me just double check. One second. I don't think I see this on LinkedIn. Oh, there we are. There was just a little lag. Okay, awesome. Let me just turn that off. Good morning, afternoon, or evening, everyone, depending on where you are. Yeah, so if you're here, you're curious about data validation in the context of data pipelines and machine learning pipelines. And yeah, today let's learn a little bit about this. My name is Neil Bentielen. I'm the Chief ML Engineer at Union, where we are helping development teams, engineering teams build AI applications. Today I have my open source hat on, and I'll be giving you a brief intro into data validation with a package that I authored called Pandera. If you're tuning in from LinkedIn or YouTube, just feel free to go to the comment section and chime in if you have any questions or comments. Happy to take these throughout the workshop. So for the next hour, we'll be learning about data validation and why it's important, what kinds of problems it solves, and without further ado, I'll share my screen here. Get some logistical things out of the way. I'm going to paste into the chat the GitHub repo that we'll be using to develop our intuition around this topic. Get our hands a little dirty. And the first thing you need is a GitHub account. Hopefully, most of you have that. Once you do, please go ahead and sign up for Union. This is our serverless platform that allows you to run workflows and machine learning, data applications, AI applications. We won't be going too deeply into this, but at the end of this workshop, we'll see how Pandera and data validation tools like it can be integrated into data pipelining orchestration tools, one of which is Union. So I encourage you to go ahead if you want to code along. If not, you can just go ahead and watch. This is the destination you should see once you've signed up. The sign up flow, maybe I can try showing it what it might look like here. Okay, so it sends me straight to the dashboard since I'm already logged in. But if you're maybe a new user, you'll see something like this. Go ahead and sign up. It'll ask permissions from your GitHub account for you to do a single sign-on through that. And once you have your account, it should take a few seconds, if not a few minutes, to provision your account. Once you have it, you should be able to go to serverless.union.ai and see the dashboard page. I think that is it in terms of setup. So let's dive in. I'm in this repo. I'm going to go ahead and click on this open on Google Colab. I'll just close this window. So this is the notebook we're going to use to go through this workshop. I do encourage you to click on File, Save a Copy, and Drive. I'm going to do that right now. Just so when you noodle around with this, you'll be able to save your work in case you wanted that. First thing we'll do before anything else is we'll set up our requirements. This is going to clone the Pandera workshop repo and install the dependencies that we're going to be working with. And while that's happening, let me take you through kind of the outline here. So zoom in a bit. This workshop is structured into 4 parts. We're going to start off understanding why data quality matters. What are the challenges? What are the negative outcomes of not doing it in data-driven applications? I'll introduce you to Pandera, some of the core concepts, how to define schemas and checks, and validation strategies. This is a very broad topic, but I'm hoping to kind of condense it. We'll do a little hands-on demo of kind of a real-world security application or a security defense measure that you can take against what's called data poisoning attacks. So we'll have a little toy version of this. And then finally, we'll integrate it with workflows, in this case, the Union platform. And you'll see it should look very familiar if you are familiar with Python. It's basically functions with a bunch of decorators to compose the steps in your pipeline. Okay, so heading down here, why does data quality matter? There are a lot of these, but the common data quality challenges that I see in my own experience and kind of out there in the world falls into roughly 4 buckets. Of course, there are actually many more, and kind of you can pick these apart to learn to be even more granular about the data quality challenges. But you see things like data type errors, data type mismatches. You expect integer, except you get a float, or the other way around. You have out of range values, meaning that logically speaking, a certain column should be, say, positive numbers, but invalid values would be negative numbers. You have missing values. Oftentimes in data collection can be quite noisy and there can be missing values, but it would be nice to be able to enforce the fact that you don't expect any to be in a particular column or field. Data drift is a kind of a thorny one. This is when the distribution of the underlying data you're working with changes, either as a single variable or the relationships between the variables change over time. So a simple example of this would be, let's say, the consumption behavior of people during the pandemic, which maybe broke many recommendation systems and recommendation models. But there are many ways in which this can manifest as well. Yeah, if you're just popping in, please say hi, do a little wave in the chat. It's always nice to see little activity there, so please don't be shy. So this can actually lead to hours debugging data pipelines. If a data error somehow silently passed through your pipeline and you're seeing some weird behavior in your model, or you're seeing some strange plots that are being output by your reporting layer, which are these next 2 points, your model performance can degrade, and you could make the incorrect statistical inferences or decision making from invalid data. Okay, so instead of just telling you these things, maybe show you some toy examples of what may happen, right? So we're going to be using pandas throughout this workshop, very common tool for data frame and kind of like tabular data manipulation. We have a very simple set of data here that kind of look like dates, but I'm not doing anything special. And if I'm kind of naive and assume that pandas can handle this automatically, go ahead and define these dates. They look like dates, but they're actually strings. So if I try doing an operation like subtracting some timestamp from it, it will complain. So the operand, the subtraction operand doesn't work for between timestamps and D arrays. It's actually maybe a bug. Let me just check. I'm going to go ahead and select this column. Yeah, same bug. So this is a very simple illustration of if you assume that the framework, the data framework you're using can kind of automatically parse raw data, then it's actually better to be a little more explicit about it, right? So the way you would maybe do this is have an as type here, and then, you know, coerce the data into the right type. In which case, the computation actually does happen. Cool. Out of range values, also quite intuitive, and maybe something you've seen in practice a lot, where, you know, let's assume that prices are positive, unless someone, the grocer pays you to buy the bananas, which doesn't make sense. So like having a negative value here can ruin the distribution that you're working with. And so if you're computing statistics or something like this, like a mean, you'll get some very strange values if you don't otherwise handle these kinds of potentially corrupted values. Missing values, another one, right? Again, as I said earlier, missing values are par for the course for a lot of tabular data and a lot of data in general. So if you're doing any statistical modeling of these things, there are all these techniques to handle these cases. But if you're using a framework like scikit-learn to fit a model, many models don't automatically handle null values. So you're going to have to either remove the rows or do some kind of imputation. So, you know, let's go ahead and define our little toy housing data set. You have price, number of bathrooms and bedrooms, and square footage. So, you know, naively, we can just try to fit a scikit-learn model on this, and it will complain that it cannot accept null values. So these are kind of obvious, right? Because your pipeline is going to blow up. You know, your training pipeline, training script will raise an error. So at least you know what's happening. This next one around data drift, as I said earlier, is kind of a pain because oftentimes you have all the columns there, they're all the right types, they're all kind of valid values, but as I said earlier, the distribution changes. So to illustrate this, here's a little code snippet that generates some synthetic data. You know, we have the data at time point 1, and you know, it has a mean of 0 and a standard deviation of 1. Let's say data at time point 2 has a mean of 2 and a standard deviation of 1.5. I'm not sure if this is variance or standard deviation. Anyway, regardless, we're going to derive a target from the data at time point 1 and just introduce some additional noise to it. And this kind of simulates that data at T1 and the target are correlated, whereas at T2, they should be independent, right? So if I plot this out, we see that the data has shifted. This is histograms and density plots are a common way to try to visualize this. And if I do a scatter plot of the target against data T1 versus data T2, you can see the relationship has vanished kind of by design, right? But this can happen to your real data, where some variable, in this case T1, is informative to predict a target, but then at some point in the future, just is no longer informative. Okay, so hopefully I've given you some background here of some common challenges, from fairly simple to address to a little bit harder to address because of its statistical nature. So Pandera kind of covers all of it. And in terms of increasing complexity and customization, you can implement a lot of the checks that will allow you to prevent, you know, data errors silently passing, or at least pinpointing exactly where in your pipeline things fail if say, corrupt values are introduced at some point. Okay, so we're back at this housing data frame that we created above. Let's go through each of these cases, right? So we have data type errors, we have in-domain errors within a certain range or finite set of valid values. You have missing values, and then you have data shift. So for this intro, I'll kind of gently go into each of these. And again, if you have any questions as they come up, please feel free to add to the chat. Okay, so if you're familiar with data classes or Pydantic, Pandera's syntax is actually quite similar. It's inspired by these libraries. So first thing we do is import Pandera, and we're going to define just a data type to column mapping, essentially. So we create a data frame model. We subclass it to create a housing schema. And we define these 4 columns: price, bedrooms, bathrooms, square footage. And we define the data types of each. Maybe I would question bathrooms as a float, but let's keep it for now. I guess you can have 2.5 bathrooms. So, okay, never mind, I take that back. Okay, so that's fine. And we can actually, I'll just define a cell below. And the way you validate data frames directly kind of in line is through the validate method. So some interesting warnings. Yep, price contains null values. I actually wanted to show you this later. You can ignore these warnings, actually. But this warning, this error, the schema error came up because the price column has null values here. And by default, it doesn't allow that. So I'm going to go ahead and delete the cell. We'll come back to this a little bit later. Oops. The next step is to encode the allowable values per column, right? So we're just redefining housing schema here, but we're kind of encoding some of our domain knowledge. Let's say we've looked at the data set, we've analyzed it, we did some exploratory data analysis, and now we have a fairly good mental model of what counts as valid data. Now, we then can directly encode this understanding as this in this kind of declarative way, where we just say, hey, price in today's housing market can't be more than $50,000, let's say. I mean, much more expensive than this these days. Minimum number of bedrooms is 1. If you're in a studio, it's 1 bedroom. Number of bathrooms, minimum is 1, and square footage, let's say minimum is 100 square feet. So now we're getting a little bit, we're layering on top more assumptions about what valid data looks like. Here, all we're saying is these are the columns that exist and these are their types. Here, we're saying an additional set of constraints around what the allowable values are. And as I said earlier, if I try to run this, it's going to raise an error. So I'm just catching it and putting it out here. Price contains null values, right? So let's go ahead and do a little off-the-cuff cleaning. Let's just do the simple thing and drop null values, any entries with null values. So now we have a nice clean data set. And this should pass. So actually, let me validate schema, validate. Oh boy, I need to do some more cleaning. So price actually turned out to be a string. I did not plan this, I swear. Oh, more issues. Okay. So let's go ahead and fix this more nicely. And we can actually do this by saying, adding a config class here and say coerce equals true. And what this will do is it will coerce the types of all the incoming raw data into the expected type before running any of the other validation checks. So let's see if this worked. And boom. The programming model of Pandera is that for any schema that you call validate on, if the validation passes, it'll just return the data set with the data frame. If it fails, it'll raise an error. So if it fails, you need to try except to sort of do anything else with the results of the validation. Okay, there's a little bit more to say there, but I do want to move on, so maybe I can circle back to that. Finally, for data drift, what we can do here is actually define. So this is our schema. We're just kind of redefining it with a new name. So all this stuff here should be familiar. But on top of this, we're adding a data frame check. So this is a class method, as you can see here in the first argument class. And what this does is it allows you to define custom checks. And so a data frame check will expect here to pass the data frame that you're trying to validate. And as long as you return a Boolean, a series Boolean, or a data frame Boolean of the same shape, you can implement whatever validation check you want here. So in this case, we are just making sure that the correlation between the price and all of these features is positive, right? So if you just eyeball this toy data set, you can see, yes, it literally just, each of these are just exactly the same, just modified by some multiplier or some offset. So that's the way you write custom checks. You can do a custom column level check by just saying the check and then saying what you want to validate here. So that's how you do that. But for now, let's just go ahead and run this. And we're passing all of our checks, right? Let's take a look at a case where there's some data drift, or in this case, straight up corruption of the data. So we're just flipping the bedrooms column and reverse sorting it so that you end up, with data frame that looks like this, where the bedrooms actually decrease as the price increases. So let's go ahead and try this. So this actually raises a error here that says, hey, their check price correlation validation rule didn't pass. So this is the way you would now implement statistical distribution checks on the data, and you can just kind of encode it directly into your data frame model class. Okay, cool. So hopefully that gives you a good sense of what you can do with Pandera kind of manually. And so I do this fairly often when I'm working with data, just creating these schemas, these data frame models. Usually it's just going to be column and type checks, but then I'll add maybe some value constraint checks just so that the very baseline of valid data is maintained. And it's also a nice thing where if someone, a colleague or me in the future goes and looks at this notebook, I can see directly here, just in the code itself, what counts as valid data and what columns I would expect to see in my data frame. Okay, cool. So we're almost halfway through. Just want to take a break here in case there are any questions. Okay, let's move on. So let's do a hands-on demo of something a little bit more realistic. We'll still be using kind of smaller data sets that are from the UCI data repository. But we're going to implement a pipeline where we're going to try to attack it with a common machine learning attack, which is label flipping. So label flipping is, as the name suggests, when you say have a binary target in your data set, and you just flip some random sets of labels. And so this is a data poisoning attack that can degrade the performance of your model. So we're going to see that in a second. So the first thing we're going to do is we're going to fetch the heart disease data. I've implemented a few kind of data cleaning steps here just to start. And we're just going to binarize the target. So target in the native data set, I believe, check this in the schema we define here. Yeah, is greater or equal to 0, and it kind of like the degree of the heart disease progression goes up to 4. A little bit of preview there. Let me find where I'm at. Okay. So in this case, we're just going to go ahead and binarize the data off the bat. So let's go ahead and run this code cell. You can see that we have a table of all these features, and then the target for predicting heart disease based on all of these features. So let's go ahead and implement a little function that poisons the data. So it takes in the data frame. You specify what percent of that data you want to poison in some random state to make it a little deterministic. And the main thing to pay attention to here is we're just flipping the label of the target column based on the random sampling. So if we take a look at the poisoned data, everything looks good, like from all of our other data type checks, value checks, and missing data. Everything checks out, except now if you look at the relative proportion of 0 being no heart disease and 1 being it has heart disease, we look at the poison target and we see that the proportions have slightly changed, right? It may not be good enough to do target proportion checks, right? Because if the attacker is careful, they can just kind of, they have access. So just to take a step back, in this attack vector, really we assume that the attacker has somehow gotten access to your data store, be it a data lake like S3, a blob store like S3 or GCS or something like that. They've somehow found a way to corrupt data. So you can think that just measuring kind of the relative proportion of the targets is enough. But there are ways that you can flip the labels in just such a way as to make the proportions not too dissimilar from the original data. So there are actually other ways here, as I've alluded to here. There are other ways to detect whether data has been poisoned. And the answer is yes. So to illustrate this, I'm going to implement functions that basically build out a training pipeline. So we're going to, take in some parsed data, which is just the data that's been binarized, and we're going to split it into test and train splits. Here's just a little helper function that gets features and targets. Then we're going to train a scikit-learn random forest classifier. And then finally, put all the pieces together to create the training pipeline. So cool. Let's go ahead and run this. And you can see the training pipeline completed successfully, and the test accuracy is 81%. But if we run the same exact pipeline on the poisoned data set, the test accuracy drops to 57%. So one other way of detecting kind of model degradation, obviously, is to look at the model performance, kind of like the test set model performance. But maybe you can ask, is there yet another way of doing this even before you train the model? And in this case, the model trains very cheaply, but maybe in other cases it takes a few days for you to train a single model, and it'd be great to catch poison data beforehand, right? So the way we can do this is to do these statistical checks, right? The ones I showed you earlier that show off the custom data frame checks. So in the next section, we are going to start implementing the data frame models for this particular data set. I'm going to take a few seconds here to hop onto chat. I see here, Timothy, you're asking, I saw Pandera supports list types, but I'm interested if there's support for dict types. The answer is yes. I believe that actually might be a good time for me to show you the docs, Pandera.readthedocs.io. Let me see. They're somewhere in here. Dict types. Yeah, so the pandas engine for Pandera has a Python typed dict. Let me see if I can, yeah, so you can use this. Hopefully there's a code example somewhere. You'll be able to use just the regular dictionaries like so. So let me just hop on here really quickly. So this should work. Types like this. The way this is actually stored as in the pandas data frame, assuming you're using pandas, is as objects, right? So what happens under the hood is that it uses type guard to make sure the values are the right type. Cool. Let's see. Yeah, it's somewhere in there. I'll dig it up and I'll post it on the LinkedIn comment thread after this. If you're using polars, so Pandera also supports polars and PySpark. If you're using those frameworks, Pandera will accept like whatever native data type system that they use. So they like structs and things like that. Okay, so the first thing we're going to do for this heart disease data set is we're going to create just kind of like the baseline raw data. What is the minimum viable data for my application? And so this includes all the columns. As you can see here, sometimes you might want to annotate in comments like what specific numbers mean. We're saying what the min-max range is for the age, et cetera, et cetera. Quick note here, we're saying we want to coerce the types at validation time. And strict equals filter here actually will be strict about throwing away columns that are not specified here, right? So if I call schema.validate on a data frame that has a column called foo, and if foo isn't specified as a column here, as an attribute here, then it'll just automatically remove that column. So let's go ahead and define the schema. The next schema we'll define is parse data, right? So we defined raw data above. And the nice thing about this is I can inherit from other data frame models such that I can kind of additively modify the schema and kind of express what's supposed to happen in my pipeline, right? So initially I have raw data, and then there's some computation that happens that should produce some kind of parsed data that now has only binary targets as opposed to this categorical target, right? So this inheritance implies transformations in between that need to happen to make these validation rules pass. And finally, we inherit from parse data to create training data. And this is the moment right before we start training. We're going to make sure that, I created these data frame checks for you beforehand. Basically, these check that, things that we know should in general be true about the data will hold true. So in this case, the cholesterol of people without heart disease should be, in general, on average, lower than the cholesterol levels of those with heart disease. And we can express these each in their own method. This one is for max heart rate. This is for exercise-induced angina. And the last one just does some feature correlations like we saw earlier in the housing price data set between the target and some, 3 sets of variables. So all we're saying is, these, looked at the data and we should know that they are positively correlated with the target. If you have a statistics background, you can use any library in here, right? So if you have a dependency on SciPy or any other kind of statistical scientific computing library, you can implement any sort of statistical distribution hypothesis check inside this method. Okay, cool. So let's go ahead and define the parse data model and the training data model. And just to check, let's go ahead and validate it. So cool, nothing happened here, which means all the tests pass. And let's validate. Lazy equals true just means that we're validating all possible properties that can be validated before returning an error or raising an error. So in this case, we're catching this schema errors exception. And we see a fairly nice kind of readable error report here, just in plain text, about which of the checks failed. So in this case, all of the custom validations we defined above failed. Okay, so now we have our schemas, we have our initial version of our pipeline. How do we integrate this so that it all works with minimal code changes? So assume you have a pipeline already that does all of these steps. How do I make sure that Pandera is doing its job without having to add too many things in line? And the way we're going to do this is we're going to use type hints. So as you can see here in the parse raw data step, we are importing this special Pandera data frame type. You can think of this as just a very thin wrapper around the pandas data frame. For the other frameworks like polars, there's also a custom class for this. More to say on this, I think it's useful to support annotated types, so you can use the native pandas.dataframe type. But anyway, all that aside, the way you do this is you take your data frame type as a generic and you specify in the first argument the raw data schema. And so the way you express the output of this function is doing the same thing, but saying, this is going to output parse data. And to actually check it at runtime, you decorate the function with this check types decorator. We're going to say lazy equals true so that it does as much of the validation checks before raising an error. And that's all you have to do. Basically, every time you call parse raw data, it's going to do the runtime checks of the inputs before calling the function body. And then once it returns, it'll do the runtime check on the output as well. So we do this for all the other steps you saw above. For the split data step, I'm going to add our decorator and our type hint. Data splits just is this name tuple above here that is like a nice human readable way of saying what your training set and test set are. And they're both parse data. And we're going to do the same thing, exact thing with train model here. And that's basically it. This is how you integrate Pandera into your existing pipelines. This works for methods as well. So that should work if you prefer using classes. Okay, so let's take it for a spin. Let's go ahead and invoke training pipeline. You can see we get 80%, roughly 80% test accuracy. And now let's run it on our poison data. So it ran through the parsing step and the splitting step. And once it got to the training data step, what happened was it did the check and it raised an error even before running any of the code in here. So again, just going back to this point of trying to catch these kinds of issues as soon as possible where feasible. And it would be nice to do that before you spend a bunch of money and time training the model. Okay, making some good progress here. Cool. So that's pretty much it for the hands-on demo. Just to like tie it back to the ML security angle, you have an attacker. They've surreptitiously gotten access to your blob store. They corrupted your data. They did some label clipping, and they want to like destroy your business or whatever, make your model degrade, and that'll cost you, lots of money in production if you do deploy this, and all your predictions start failing or outputting kind of like garbage. So this pipeline actually protects against this. It's not perfect. Attackers can surely figure ways out around these checks if they had access to it, but it's kind of a good first set of guardrails for your pipelines to make sure A, there's just basic data hygiene going on in your pipelines, and B, if there are distribution shifts, they don't necessarily have to be from attacks, but you'll know them ahead of time. What I haven't mentioned here, there's all kinds of customizations that you can do here to like not raise an error on if there's validation rule failures. So there's a lot of customization here if you want to, have some kind of different behavior to handle data errors. Awesome. So in this last section, we're going to actually see how Pandera can be integrated into a data and ML orchestrator. So just full disclosure, I'm one of the maintainers of Flight, and Flight is the foundation on which the Union platform is built. Unit extends it to provide an even more kind of full stack end-to-end experience for machine learning and AI. But Pandera does integrate with any other tool you can think of, right? It may not be a kind of first-class integration, but anywhere you have Python code where you can install Pandera, you can use it. Other notable integrations with orchestrators would be, Dagster, so that Pandera also has a first-class integration there. But again, you can use it with Airflow or any other pipelining tool you're currently using. But to illustrate the point here, I've actually taken the liberty to write out our pipeline into a workflow. So I'll do a very, very quick crash course on Union, but all this should be fairly familiar. The main thing we're doing here is importing Union, the SDK, and we're defining an image spec. So this actually defines a Docker file for you, basically, a container that will run our application. So hopefully you'll be able, if you've gotten this far and if you're coding along, you've gotten to the serverless.union.ai dashboard. We're actually going to run our little machine learning pipeline on the union cluster. So let's see how we're going to do that. Here's the raw data, Pandera data frame model, the parse data, training data. So just move them all into this Python module. These are data splits. We're familiar with this. And now here's the interesting part, where we can define essentially microservices. So you can almost think of these as Lambda functions that are run in their own container, right? So they run with using this container image we defined up here. And we're decorating the functions with union task. And what this says is, hey, I want you to run this function by itself in its own container in an isolated fashion. And this might feel like overkill, but it is super nice when you have a lot of granularity in the way you can control basically the steps of your pipeline. And so, for example, a quick example would be if I'm working on one piece of the pipeline and my colleague is working on another, we might be using different versions of pandas, or we might be using different versions of scikit-learn or PyTorch or something, or there's some dependency conflict between our steps. We can actually have different images here per step and not step on each other's toes. You can also request specific resources here. So there's a request argument that we won't get to today, where you can specify resources for GPUs and CPUs, and you just ask for them, and you will be given these things as long as your union cluster has access to them. So we're going to decorate all of our functions that we saw earlier in the notebook in union.task. So we have our split data one. And again, all of the type annotations here with Pandera are, you don't have to change anything. You have their train model task, evaluate model, and in the end, we compose it all together into a union workflow. So again, this is just a function, but it is a DSL. So just heads up there that this workflow function actually is a subset of Python where you can do just kind of a limited set of operations, mostly to compose your tasks together into a bigger pipeline. So basically, all I've done is I've copied all the code over in the notebook over here. So all this code is just pure Python. And then I've moved it into this workflow file, just because I'm maybe getting ready to productionize this application. And the way we can run this is through the command line. So we'll just run these through the notebook. I'm going to go ahead and write our data sets to files. So you can see them over here. And first, we're going to authenticate our session onto serverless. So you should see this URL that you can go visit to activate your device, in which case is this Colab server. You should see a successful login here. So I'm going to run these concurrently because Union can handle that. And the first run, we're going to give it the original clean data set. And in the second run, we're going to give it the poison data set. And to wrap up this entire workshop, I'm going to show you the Union UI and how you can visualize the pipeline as it progresses, and also how Pandera integrates with the kind of the DAG visualization we see here. So this is the Union serverless execution dashboard. So this execution is what we ran over in this top command. And as you can see, there's a node view, there's a graph view for you to see the nodes in the DAG and their dependencies, and a timeline view to see how much each step took. So this is the clean data set. The poison data set is over here. And fingers crossed, we should see an error cropping up in the data set. Okay, awesome. So with a clean data set over here, we successfully trained the model. One thing I just want to point out here is the decks, which are basically static HTML reports. And you'll see a bunch of tabs, including the timeline. But I want to show you this Pandera report. So this shows that validation succeeded, nothing much to report here. This is the serialized, or like the string representation of the data frame schema we defined, kind of a little data preview here. You can do the same with the parse data. So this is the output of this parse data task. The nice part is we errored early here, so we didn't even train the model yet. And we can see the error directly in the error trace on the platform, but you can also see that the data validation report here failed, 6 failures, and you can see which of these failed. So in this case, the 3 custom checks that we defined failed because of the label flipping attack. So yeah, that's pretty much it for this workshop. Basically, the whole point of Pandera is that you can catch these kinds of data errors and bugs as early as possible in your pipeline. So you can spend less time trying to find out and debug where exactly the errors happened, what exact value caused the error. And you can spend more time, improving your model and data products and, improving your ML systems and data systems more broadly. And with that, I think I will wrap up, and I'll stick around for a few minutes in case anyone has questions. There are some resources here at the bottom of this Colab notebook, the Pandera documentation that I pointed to earlier. There's more documentation on Union if you're interested in learning a little bit more about the Union platform and how you can orchestrate complex, scalable applications. You can contact us here at our website, union.ai, and you can join our Slack community if you want to learn a little bit more and get involved with the community. Awesome. Thanks all, and I'll stick around if there are any questions. Oh, Timothy, yeah. This is very much a wish list item right now. Super big fan of the Narwhals project and also Polars. So I think last year we added Polar support. And as far as I can see, Narwhals is getting a lot of traction. There's a lot of development energy around that. So I could be wrong here. Let me know if I'm off base, but it currently supports polars and pandas, right? There may be some other libraries they're adding support for. But as far as Pandera users are concerned, it shouldn't mean, I guess if you're writing narwhal's data frames, that would be kind of one point of integration. But if you're, say, a polars or pandas user, you could there should be a mechanism to kind of select which backend you use. And so right now there's only, obviously a single backend for pandas and a single backend for polars, and a single backend for PySpark. The pandas backend has all sorts of variants for like modem and Dask and things like that. But for narwhals, it would be, I'd expect some kind of user API where you kind of select the backend, like say Pandera.set backend to narwhals or something, and it should just use the narwhals API under the hood. Really, maybe worth a little more investigation there. But to directly answer your question, there has been no progress on this yet. It's literally just a feature request. Yeah, exactly. Awesome. Thank you so much. All right, I will end the stream now. Bye, everyone.